Hey guys, it's Kurt Gildenmeister, and I'm going to be talking about what a phospholipid is and how we can use it when cooking. First off, what is a phospholipid? It is a lipid or a fat molecule, and normally, normal lipids at least, such as triglycerides, are nonpolar and are hydrophobic, which means that they will do anything to avoid water. So if we take our normal lipid, which is a oil or fat, in this case oil, I have mixed it with water, or attempted to, and as you can see, it has formed a layer on top, avoiding the water at all costs because it's hydrophobic. It wants to stay away from it. Now, a phospholipid, on the other hand, is polar, which means that it has a hydrophilic head, which means it's attracted to water, so a nitrogen and phosphate hydrophilic head. So this will want to be attached to water at any moment. The second water comes near it, it will want to go attached to it. And then it has a long tail, which is formed with hydrocarbons, and this is hydrophobic, which means that it wants to stay as far away from water as possible. And it's also lipophilic, which means it will want to attach to oils and fats. Now what I'm going to do is show how we can use these polar characteristics to mix our oil and water. Now, when you mix oil and water, it is called an emulsification, and you can do this several different ways, either physically or chemically. And right now I'll demonstrate a physical emulsification. If I stir this up, it'll look like it's mixed. But gradually, in a few minutes, maybe not even that, it will begin to again form that layer, as we can see right there, right back on top. So it doesn't stay mixed, it doesn't stay emulsified. So to get it to stay emulsified or completely mixed, we need an emulsifier. And in this case of oil and water, I'm going to use an emulsifier that is lecithin. Lecithin can be found in egg yolk. Lecithin has these polar qualities from the phospholipids that it contains, and what happens is you'll have your water mixture and your oil, and when you stir your oil up, they'll form smaller and smaller particles, and what will happen is these phospholipids will have these tails that will attach all the way around the oil, almost containing it in a sphere, while the outside is this hydrophilic head, which is attracted to the water. So this forms a shell or a layer around the oil in a smaller particle size, and it's called a micelle, and this will help keep the oil dispersed in the water. Here I've already done this and taken the egg yolk and mixed it in with the water and oil, and you can see that it is now an emulsification and the two have not separated. Also, it is important to remember that when doing an emulsification, such as water and oil and a lecithin emulsifier, you have to decide what's going to be your continuous phase and what's your dispersed phase. In this case, I had water as my continuous phase, or the larger quantity, versus a smaller quantity, or the dispersed phase, of vegetable oil. Alright, I hope that helped, guys. Thank you very much.